Algebra 1, Section 4-4, or Chapter 4, Section 4, however you want to say it. Say it however you want, I don't care. All right, 4-4, parallel and perpendicular lines. So parallel lines, instead of writing parallel every time, I mean, we'll write it a few more times, but shorthand and the symbol for parallel is two lines like this. It's not really an 11, kind of looks like 11, but it's not. Perpendicular looks like this. It looks like kind of like an upside down T with kind of a big top on it. So parallel, perpendicular. We're going to write parallel again though. Parallel lines. We're going to do a little writing here to define this. Parallel lines. These are lines on the same plane. That do not intersect. And as part of this, the slopes are equal. All right, so let's draw an example of what parallel lines look like. Let's draw a coordinate plane here. And let's just draw a bunch of notches here to say this is my coordinate plane. So I might have two lines that are going like this. Line A and line B here. And I might have two lines over here going like this. Line C and line D over here. And the way that we can note that these are parallel is we can say C is parallel to D and A is parallel to B. Notice how C and D, these are vertical lines. So all vertical lines are parallel to one another. All right, just like all horizontal lines are parallel to each other. They have the same slope. Vertical lines, though, we say have no slope. And so we treat them a little bit special, but anyway, they're not. They just think they are. Example. Write an equation in slope-intercept form, which is y equals mx plus b, that passes through this point, 3, 5, and is parallel to y equals 2x minus 4. Whew. Okay. So let's go ahead and let's talk about what we're trying to do here first. Okay. So we're trying to find the equation of a line in y equals mx plus b in slope-intercept form that is parallel to this line, but it contains this point. Okay, I know that my slopes for parallel lines, the slopes are going to be equal. So really what I'm saying here is find the equation of a line that passes through this point and has a slope of 2. That's really what I'm saying here. That's really what we're being asked to do, which is something that we've already done here in this chapter. So I'm going to label this x and y, and I'm going to say y equals my slope, which is 2 times x. I don't know what my y-intercept is going to be because this is a different line. So I have the same slope, different y-intercept. So I'm going to say plus b. I don't know what my y-intercept is going to be, but I do have a point that lies on this line. And so what I do is I just plug in my point. Negative 3 for my x and 5 for my y value. 5 equals negative 3 times 2, which is negative 6, plus b. Add 6. 11 equals b. And so now what's the equation of my line? Y equals my slope, which is 2x plus 11. There I have written the equation of my line. Now let's just graph this just to see what's happening here. I gotta go all the way up to 11. All right, so for this line here, I go down to negative 4, that's my y-intercept, and then my slope is 2 over 1, so up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and there's my line looking like that. Now same thing with this, this other line, so I go up to 11, I go up 2 to the right 1, oh that's not really right, is there? Up 2, I'm going to go down 2 to the left 1 as well, and then here's my line. And if I were to draw my graph, perfectly, like this is not totally perfect, but these lines should be going exactly the same direction without ever touching. So like for instance here, like eventually these two would actually touch because of the way I drew them, but they shouldn't ever touch. These should be parallel, meaning they will continually go on forever, the same distance apart from one another, never to actually get to meet. Sad. Okay, let's do another one. Same prompt here, but I'm not going to write all that again. I've got a point that's 4, negative 1, and I've got a line. So I'm going to try to draw a line, write the equation of a line that's parallel to y equals 1/4 x plus 7. So here's my point. Here's the line I want to be parallel to. This is the guy that tells me what my slope needs to be if my line is going to be parallel to this one. It's 1/4. So x, y equals my slope, which is 1/4 times x, plus I don't know what my y-intercept is going to be yet, but I'm going to plug in these points to see if I can find out, or this point I should say, sorry. Negative 1 equals 1/4 of 4 is 1 plus b. I'm going to subtract 1 from both sides. 1 and negative 1 is 0. Negative 1 and negative 1 is negative 2. So my y-intercept is negative 2. So now I just rewrite this whole guy again. Y equals 1/4 x minus 2. And I have completed my equation. Let's have you do one. 2 is my point, and it's parallel to my equation, which is y equals x plus 3. All right, so as you get started, this here, there's a 1 here, because it's just 1x. So it's your slope is 1. And go ahead and get to work on this, and we'll look at it when you're done. Go. All right. X, y, let's see how you did. Labeled this here. My slope is 1, so y equals 1x plus b. Plug in 2 for both of these guys. And then I've got 2 equals 2 plus b. Subtract 2 from both sides. 2 minus 2 is 0, so b equals 0. So I rewrite my equation, y equals x plus 0. Do I need to write plus 0? No, I don't need to write plus 0. So here's my answer, y equals x. So this line here, y equals x, is parallel to this line here, y equals x plus 3. This one goes through the origin. This one, right here where my y-intercept is 0. So it goes through the origin, like this. And this one does the same thing, except we're not going through the origin. It has the same slope. It goes like this. There we go. All right, let's do a few more examples here. Oh, we're talking about perpendicular lines now. All right, we're going to write perpendicular again. Hopefully this is the last time we have to write this enormous word. Perpendicular lines. And remember, perpendicular, we notate like that, so we don't destroy our finger. My finger hurts from all this writing. All right, perpendicular lines, they cross each other at a 90-degree angle. That's what it means to be perpendicular. 90-degree angle. And the slopes are opposite reciprocals. Opposite reciprocals. Okay. So opposite means plus to minus, or minus to plus. Okay. Reciprocals is something else, like 4/1 to 1/4. It means you switch the numerator and the denominator. So let's do some examples. Let's do 1/5. So the opposite reciprocal of 1/5 is 5/1, but I need to change it from positive to negative, so negative 5/1, which is just negative 5, right? Let's do another one. Let's try negative 6. Negative 6, the opposite reciprocal of negative 6 is 1/6. I need to change it from positive. I need to put the numerator and make that the denominator, make the denominator, which is a 1 here, and make that the numerator. One more. 3/2. The opposite reciprocal of 3/2 is negative, so this is positive, so it's got to be negative. And then the 2 goes on the top, the 3 goes on the bottom, opposite reciprocal, there we go. Now, let's figure out how to do this with a line. So here's my example. I've got a point that is -4, 6, and this line is perpendicular to 2x plus 3y equals 12. Oh man, now I'm in standard form, aren't I? So I want to change this. I don't know what the slope is based on just looking at this standard form. I need to change this to slope-intercept form so that I can find out what the slope is, because the slope is what's going to really help me here. So I got to subtract 2x from both sides. So I have 3y equals -2x plus 12. Then I need to divide everything by 3. And I have y equals -2/3 x plus 3. 12 divided by 3 is 4. Okay. Slope-intercept form. Now I know what my slope is. There's my slope. So that's the slope of my original line here. I want the one that is going to be perpendicular to this. So I need to take this slope and I need to change it to positive 3/2. So I took my opposite reciprocal here. Now that's my slope of my line that is perpendicular to this one. So let's go ahead and do what we've already done here. Y equals mx plus b. My slope is 3/2. And then I multiply that by x. And I don't know what my y-intercept is yet. But I do know that x is -4 and y is 6. So I'm going to plug in 6. And I'm going to plug in -4 for my y and my x value. So I get 6 equals -4 times 3 is -12. -12 divided by 2 is -6. -6 plus b. Add 6 to both sides. 12 equals b. So my equation is going to be y equals 3/2 x plus 12. And this equation is perpendicular to this equation. Now we could change this back to standard form, but I don't feel like it. Let's have you do one of these guys. So I've got 4, 7 is my point on a line that is perpendicular to y equals 2/3 x minus 1. Oh, isn't that nice? We have it already in slope-intercept form. Take my slope, find the opposite reciprocal of it, start your equation, find the y-intercept, boom, you're all done, rewrite it. Okay, pause and do this one. Okay, let's see how you did. All right, y equals, my opposite reciprocal of this is -3/2 times x plus my y-intercept. 4 is x, 7 is y, so I'm going to plug 7 in for y, and I'm going to plug 4 in for x, and now, got 7 equals, okay, 4 times 3 is 12, 12 divided by 2 is 6, and I've got a negative here, so -6 plus b. Going to add 6 to both sides. Feels like we've already done this problem, huh? 13 equals b. So now I just need to rewrite my equation with my slope and my y-intercept. Y equals -3/2 x plus 13. This line is perpendicular to this line because I have opposite and reciprocal slopes. And that is the end of 4-4.